Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 4.2.3. We're going to start off with our M&Ms for proportional relationships. Okay, so a relationship is proportional if one quantity is a multiple of the other. This relationship can be identified in tables, graphs, and in equations. So remember, when you're looking at the table, look for equivalent ratios. You can look for the constant multiplier within the table. For instance, what do you multiply times 3 to give you 7? You multiply the same thing times 6 to give you 14, the same thing times 9 to give you 21, and so on and so forth. Of course, we're looking for 0, 0 to show up in the table. And what this is mentioning up here about equivalent ratios, remember, we take any two of these ratios and we write them as such. Oh, no, 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 no. If you take 3 over 7, that should be equivalent to 9 over 21. Look to see that either the cross products are equal, or look to see if you can see a giant 1. 7 times 3 is 21, and 3 times 3 is 9. Yes, those are equivalent to each other. That is proof that this is an equivalent, that this is proportional in nature. Okay. What else are we looking for? You're looking at a graph. If the graph is a straight line, that implies there's a constant growth rate, and it has passed through 0, 0, just like we see 0, 0 showing up here. The last thing that we haven't talked about so much is what the equation looks like. If it's in the form y equals kx, k is like the unit rate, or what we call the constant of proportionality in mathematical terms. But it really is a unit rate where, say, this is a little bit of a complicated example. 3 pounds for $7. What I would prefer that we do is take what is 7 divided by 3. It ends up being equal to, what is that, 2 1/3. So that would be like 2.33 repeated. But what we would probably do is just write it like this. We would round it off. So it looks like every one of these numbers gets multiplied times 2.3 repeated, and you get this as your answer. Let's go ahead and check that. Let's say if I multiply 9 times 2.3, and I'm going to do the repeating kind of an action there, not rounding it off. Let's see if we don't get the answer of 21, and yes, we do. So that is our unit rate. It's also the multiplier, whatever we multiply times x to give us y for an answer. So then it really comes down to being able to read through a problem and recognize that the problem is proportional in nature. So if 3 pounds of chicken costs $7, what would it cost for X pounds? Well, if you don't buy any chicken, you're not spending any money, right? That's the 0, 0. And we expect there to be a universal price per pound, which is what we would refer to as the unit rate. So there's your constant growth rate and your 0, 0 scenario. Now, when we look at this situation, the county fair costs $5 just to get in, $1 per ride. Now, if they did not charge you to get in, and they just charged you $1 for every ride, then it would be proportional. But they need to make their money, and they realize that a lot of people aren't going to want to go on rides. So they're going to charge $5 per person plus $1 per ride. So that really would look like this: y equals x plus 5, because we wouldn't have to say 1 times x. And then you see, okay, there is no constant multiplier. 1 times 6 is 6, but 2 times 6 is 12. So this is not proportional because of that thing being added on at the end. So basically what we have are two forms here of this equation. You got the proportional form, which is y equals kx, and you've got the non-proportional form, which in 8th grade we'll do more of an analysis in, where it's y equals mx plus b. So notice something's being added on at the end here that changes it, so it's no longer 0, 0, no longer proportional in nature. It no longer goes through the origin, although it's still a straight line because you still have a constant growth rate here, just like we had there. But it also has this dude right there that's affecting its proportionality. So this is not proportional if it's in this form. So let's take a look. Complete the proportion table. It's nice that they're telling us it is proportional. That way we know when we graph it, it's going to pass through 0, 0. So let's look for what we know. This is the one that's going to give us the information we need. if we're going to figure out what the unit rate is, that constant multiplier, we're going to have to say, all right, well, it's $2.58 for 6 pounds. How much would it be for 1 pound? And to do that, we just do the division. So let's go ahead and grab our calculator and say $2.58 divided by 6. That's going to be the price per pound. Okay, so our unit rate is 43 cents per pound. And now we can multiply it times 2 to give us 86 cents. To multiply it times 3 to give us $1.27, and so on and so forth. Now, the great thing about setting up the equation or the rule y equals 0.43x is that if they give you total cost, you can plug it in here and divide that number by 43 cents. If they give you the total number of pounds, you plug it in here and you multiply that number times 43 cents, and you can fill in all of that data. Okay, so it looks like on the graph I chose to graph this point, and of course 0, 0, and then all the other points fall into place along the way. So here it is, 86 cents for 2. Here's your unit rate. That would be 1 for 43 cents. What does this one appear to be? That's 7, right? I'm curious because that looks like it's almost exactly 1, 2. That's almost exactly 3. What is 7 times 43 cents? Is that almost exactly $3? I bet it's very, very close. So 0.43 times 7, $3.01. So it was just a touch above 3 there. Okay, so like I said in class, and like I said in my video, if you graph the points that are farthest away from each other in your table, then everything else should fall right onto the line, and it's just a matter of plotting it and labeling it. All right, the choir is planning a trip to the water park. The cost to use a school bus is $350. If we complete this graph, it ends up looking like this. It is not a straight line, and it does not go anywhere near the origin. So what is happening in a situation like this? This is actually a situation that is called an inverse. What's it called? Inversely proportional? Proportional. And so the idea is this. That's supposed to say proportional. My pen's not working very well. What happens is this. These two numbers, the x and the y value, when you multiply them together, they always are going to equal 350. These two numbers, their product is 350. If you were to take 8 times 17.5, which I guess that's $17.50 per person, it's going to be 350. So a situation like this is interesting because the cost of the bus is the cost of the bus. If nobody goes on the bus, then you're not going to even rent the bus. But if you rent it, somehow you got to cover that $350. So if only one person rides the bus, that one person pays all $350. If you were to squeeze 350 people on the bus, each one would pay $1. Not sure how you would do that, but maybe they're on the roof or something. But these are more likely scenarios of 35 people riding on the bus. You might even be able to get 70 people on the bus, and each one would pay $5. But this graph ends up being a graph where it curves, and it never ever gets to 0. They will never ever 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 get to 0. You can't have 350. You can't have a number of people on the bus where you would have to each one pay $0. It would be impossible. They got to pay something because you got to cover the cost of the bus. And then you couldn't have 0 people on the bus. So this is kind of, instead of it being in the form of y equals kx, it is actually y equals k divided by x. And if you multiply x on each side, it is also y times x is equal to k, or in this case, x times y is equal to k, where k is the $350. And that's why if this is x and this is y, the total product of all of those numbers is going to be 350, the k. So interesting kind of graph. We're not going to worry about these too much in 7th grade. This is just to inform you that these kinds of situations and graphs actually exist. All right, Paige traveled to Australia and is making her favorite bread recipe. She usually bakes bread at 350 in the oven. That's Fahrenheit, though. In Australia, they use Celsius, and this is the formula for converting from Fahrenheit to Celsius. So in order to get the equivalent Celsius, we would have to take this formula and plug in 350 degrees into the formula. And then once you've completed everything on the top, then you divide it by 9. Okay? So what is 350 minus 32? I believe that ends up being 318, if I'm not mistaken, because 32 plus 18 is 50, right? Yes, it is. So now we're going to have to multiply 5 times 318. Well, what is 5 times 300? That's 1,500. 5 times 18 is 90, so that's got to be 1,590 divided by 9. And at this point, I'm going to go ahead and use the calculator. Let me just verify. 318 times 5 is indeed 1,590, and then take that and divide it by 9, and you get 176.6 repeated. So that is the conversion. So if you want to bake it at 350, then that's the number in Celsius you're going to plug into the oven. All right, simplifying these. We need to know how to add and subtract fractions, and you've got to get common denominators. Okay, so 2/5 minus 1/6. We can't do this work unless you have a common denominator. So the common denominator in this case is going to be 30, because 5 times 6 is 30. So you can take 2/5 and multiply it times something to give you 30 in the denominator. Well, that's got to be a 6, right? So you're going to multiply the 2 times the 6 and the 5 times the 6 to get 20 or 12 over 30. Then we'll do the same thing with 1/6. What do you multiply times 6 to give you 30 for your denominator? It's got to be a 5. So multiply 1 times 5 and you get 5. So what is 12 minus 5? That's 7. So it ends up being 7/30. Here, that's a pretty easy fix. We're just going to double the 3 and the 7 to make that 6 over 14, and then you subtract 7 over 14, and you get -1 over 14. And here, I'm going to do the same thing that I did for A. Instead of finding that common denominator and multiplying times giant ones, I'm going to do the coat of arms, which we talked about way, way back in chapters 2 and 3. If I do the coat of arms, I'm essentially multiplying this denominator times the numerator and denominator. So that would be 5/8 times 3 over 3 to get me 15 over 24. Then I'm going to multiply the 8 over 8 times 2/3 to give me 16 over 24. And now when I do the subtraction, 15 minus 16 is 1, so that, or -1. So it's -1 over 24 is our final answer. All right, so last problem, I believe, right? 54, yes, that's the last problem, is a probability problem, which involves proportional reasoning. The probability of getting a white marble from a bag is 1 out of 5. Now, that's a simplified ratio. There could be 10 marbles in the bag, and 2 of them could be white. There could be 50 marbles in the bag, and 10 of them are white. We don't really know how many are in the bag. And it says here, if there are 37 marbles in the bag, we can use that to figure out how many must be the total, right? So if the simplified ratio of white marbles to total marbles was 1 out of 5, and we know there are 37 white marbles, we can figure out how many total marbles are in there by using our proportional reasoning. So here, what are we multiplying times 1 to give us 37? That would be 37. So we're going to multiply 5 times 37 because that is our giant 1. And we end up getting 185 as our final answer. Okay, so doing proportional reasoning involved with probability is something that we do fairly often, and we're just going to use the same strategies what we use for all other proportional types of problems. You can do it that way, or you could set it up as 1 over 5 times 37 over x. And remember, we could do the cross multiplication, where 1x is now equal to 5 times 37, and you get your answer that way too. So either way, you're going to be multiplying 5 times 37 to to get to this answer. And that, by the way, is supposed to be an X there, so let me fix it. All right, so that concludes this almost 15 minutes, a little bit longer because of our explanation for M&Ms. All right, take care. On to the next activity. Bye-bye. Bye.
Hey, feeling